You know all about databases, you know all about Hadoop, and you know all about the combination of Hadoop and Microsoft SQL Server. Can you sketch how Hadoop started to change the database world?
Sure, thanks Tony. So Hadoop made one big change to begin with. It commoditized how we deal with big storage. Right, so before this is like when we had to scale up a system or to scale a system, there was hardly only one possibility, that was scale it up. And that meant it's like you buy expensive SAN, you buy bigger machines, and we all know if we go above 4 sockets, you pay a premium. And so scaling up warehouses or databases was a big challenge. And so what the Hadoop ecosystem tried to do was like commoditize how we deal with big sets of data. First of all, by providing a storage layer that is built on just commodity boxes and by striping it. So they took the approach that you use in a SAN disk, where we're striping data over multiple disks. They took that approach and they implemented that over multiple nodes. And of course this was derived from the Google file system work that was under the underpinning of Hadoop and HDFS. Now you have a disk fabric, a block-based storage fabric over very cheap nodes. And they built in high availability. So they knew, because it was a distributed system, it would fail. And because they designed for it, they basically could take out a node, replace it, lose no data. Because they had an availability factor that is configurable at a minimum 3, default is 5, so they were very reliable. Now it's like you needed a processing mechanism, so that's where MapReduce came in. Another invention came out of Google, right? That basically drove their search engine, and that allows us to distribute the work to all those nodes. So now it's like you made a single machine problem and created it a massive parallel problem. And so you would scale out, you would distribute the work to all these very low-end nodes, but combined they had much more power and they were much cheaper. And so the two things combined, the processing power and the reduced cost, is a big motivation to actually drive into an Hadoop kind of distributed compute world. So that was the first step actually of what Hadoop meant. Now of course there's a lot of data that we already have in databases, spreadsheets, like the whole thing. And so the biggest thing is like, what is Hadoop actually giving us? And so one of the aspects it does give us is it can do work for us that we already do today in a very different way, much more efficiently. So I'll give you an example of what we do. So we have, one of the things I'm working on is like catalogs for the Windows Store and the Windows Phone Store and the Xbox Store. And catalog is read-only data. And so we had this problem, it's like we have different types of information in the catalog. We have games, we have apps, we have videos, and we have music, and they all come from different places. So you have an ingestion process that puts those things in what we call the master catalog. And we store that actually in an Azure table storage.
It's a big table, right?
It's a big table, right? And now it's like we need to have catalogs that can be used at every edge for every device type. So we need to scale that out horizontally, because if the load increases, so you can't use one database. That we already know that doesn't work. So we use actually Hadoop as a model to pull things out of, in our case, Azure table storage. Then we cook it through MapReduce jobs, which processes over the streams and pushes that into a database, a SQL Server database using Scoop, which is one of the projects in the Hadoop ecosystem. So now what we have as a result is a catalog inside the SQL database, which is completely disposable. And that is a rinse-repeat process. So the efficiency there is like, we can take that database and just horizontally scale it based on our needs and the load of the system. We can recreate that catalog within a time frame of 2 hours today. And if the requirements change, what do? Well, we change the cooking process. And now we have a different style of catalog. Or if you come to me and says like, well, it would be good if we have this new dimension inside our catalog, which we didn't think about before. Well, that's fine. We'll just change our cooking rules and we'll produce a new one. So that's a great example of how Hadoop actually allowed us to take a well-known problem and approach it differently at a much lower cost. But also with much better results, because the fidelity of those catalogs is much higher now, because all our learning is in the cooking jobs,
right?
And it's a repeatable process. And so that's one case. The other example where it's like it actually will make a big change, I think, is in the data warehousing market.
Right.
You all know is like the big data warehousing projects, and it's like we need to get insights into data. But it's like to build a big data warehouse. that's a massive investment, and even for large companies, it's like you need the storage space. It all needs to be in place in one ginormous place where it's like you can make all the correlations, and so that made those warehouses very expensive. The other part of the warehousing projects which made it problematic in the past is that you don't know ahead of time which questions you're going to ask.
Right.
And
so you have to be prepared for everything.
Yes. And so you either had the monster warehouse, which many projects failed, or you had what they call the data marts, which were driven by business units or departments, which knew which questions to ask, and those were most of the time successful. But what did these data marts projects do? They took a big pile of data and they reduced it down to a small pile of data so they can manage it and they could fit within their tool chain. The problem with that approach is that they're throwing away information while doing this. Now, one new question and you come to the realization is like, oops, that data I have at the source, but I don't bring it in. So now it's like you need to go back and you need to correlate it back. This is why we have slowly changing dimensions. Wow, because it's like we are bringing back data which we needed to correlate back. And we all know how much money we're spending on those projects. And so within the Hadoop world, the idea is like you have this cheap storage fabric. So you basically, the idea is that you pump everything in. So we do that for our analytics, for example, for all our services. We take all our log files and we stream them into HDFS.
Hadoop.
Yep. Right, the Hadoop file system. And so then it's like we already have some questions. And so we create MapReduce jobs, or it's like we take Hive queries, which are turned into MapReduce jobs, to extract information out of those data streams. The good thing is like if now you come back to me and says like, well, last week we had a problem, but I don't see this in the reports or the analysis that you produced. Can you go back? Sure, we can go back. And now it's like we let the same job process the same stream, or the stream that already existed. And you can produce the data or the information that you want, because you had a new insight and you want to materialize that insight into information that you can use inside your organization. So that's the first very important aspect of a Hadoop processing pipeline. The second part is that it's like now you have those new insights, you can start to combine that with data streams from the outside. So this is a very actual topic right now, right? It's like you can combine your own data with other data. And you've seen that in sentiment analysis. Right? It's like, what is sentiment analysis? Well, it's like I have my data, I'm trying to sell books or videos. And I'm going to tap into Twitter or Facebook and I'm going to see what people write about it. And I'm going to use that information and try to correlate it in some way that I can benefit from that. Well, those are two data streams that you're going to combine. And a Hadoop environment that's what it's based on. What are search engines? How do search engines determine relevance? Well, they're combining multiple streams of data, not one, not two, really multiple. And that's how they get you your search results. Now, if you want to have reports or do forecasting based on sentiment or weather predictions, you need to start combining those data feeds. All right? If you're an insurance company, right, in the past, we took statistical analysis to determine what your premium was that you had to pay. Now it's like we can say, it's like, well, I have data about policies and all my population of people that buy insurances. And I have information about the population in general, which I can get from the government. And I can get information about a person that is publicly available these days. And if I start to correlate these things, I might be able to get you a tailor-made insurance policy. And that's where value is. And that's how companies can differentiate themselves. Addressing certain audiences or addressing a certain person.
Yeah, and people put their information right online. Yes. In the public. It's all there to grab.
It's all there. And so the amount of data is growing so fast, right? And it's like, I'm not even talking about all the devices that are now starting to generate information, right? Your cell phone already does that. It's like one of the most interesting innovations I've seen over the last year in my own area is like, we don't have all these sensors in the road where I live. And so, well, we didn't have traffic information. Now we have traffic information. I have a perfect app on my phone that shows me it's like where the traffic is, but there are no sensors. How do they do it? They tap into cell phone signals and they correlate how fast they move by triangulating them between the three cell towers.
Right.
That's public information. There is no privacy concern there because we don't need to know. It's like we just need to know how fast people or things move. And they use that to build a traffic system at a very low cost. Imagine it's like the price difference between putting all the sensors in the highways and using just cell tower information that already exists, and by correlating how fast a cell phone moves from one cell tower to the other over the highway. It's like the cost difference is enormous. Not even talking about it's like the reach that you have, because now you can cover almost every street.
Right, and the possibilities.
Yeah.
And the flexibility. Right. If you look at Hadoop and classical systems like, say, SQL Server, can you say that both are very complementary with each other?
So they both have their place.
Right.
So, and they're relational databases, especially transactional systems, they will never go away. We need those. Right, we recently had an incident which was publicly described, where it's like a Bitcoin exchange actually went bankrupt because of wrong use of technology.
Right, I think that was the concurrency in not locking of MongoDB, right?
Right, it's like they used a NoSQL database to do financial transactions, and it's the computer science 101 class of you have an ATM and you're withdrawing money. And it's like, so they were able to manipulate the system in such a way that they were withdrawing $500,000 without actually locking the resources that were associated to the account, which is like, wow, that's mind-blowing. Right? But it's the wrong tool for the wrong application. And so I'm convinced that it's like technologies like relational databases have their place. It's like there are scenarios where you need to do this. You need to have transactional consistency. You don't want to do a withdrawal without actually concurrency. But there are other places like where you have unstructured data. If you think about it as like OneNote, right, as an application, and you want to project that into the cloud. Well, what do you have a document store, but you also want to be able to search and do things on it. So you can't push that into a database. We've seen the other way around that it doesn't work either. Right? I've seen people try to build logging systems in a relational database. Like every time somebody logs into a web server, it's like we're going to write a record to a database. That doesn't scale. We know that. And so every tool has their special area where they're good at.
Right.
And what relational databases can be accused of is that they were trying to be too big of a Swiss Army knife.
Right.
They were trying to do everything.
Right.
And the people who were using them were also trying to build an even bigger, use it as an even more general Swiss Army knife, and try to solve problems with that because, like, well, it looked like a hammer and some nails, so I can get the job done by doing this. And at low scale, they're probably right. But in a services organization or a services model, that separation of concern actually makes a big difference. It makes the difference between your side being up and your side being down.
Right. That's very clear. Now, other subject, data warehousing, data sciences. Can you tell us something about that? How is Microsoft tackling that, and what's the perspective for the future? What can we expect from Microsoft?
That's a great question. So it's in terms of data science, it's probably the new buzzword of the year.
Right.
It's like I don't know which companies made the statement. Was one of the analysts that said, it's like, we need 300,000 data scientists this year to provide the skills and the resources to the companies who want to gain these insights into the data streams that I just tried to describe. And we only have 10,000 of them. And right now, it's like a data scientist needs to have a PhD in math, he needs to know how to write programs, he needs to know how to interpret the results, project them onto the business. I'm like, wow, it's like that's a very versatile person, and you pay a lot of money for that person. So we already know that model is probably not going to scale that well.
Right.
And so I think there is an opportunity, especially for Microsoft, to start thinking about is like, how can we commoditize data science, right? Because does the data scientist really need to invent new algorithms? Yeah, we need some of them, but that's a research project. And if you see how other technologies evolved, it's like, yeah, the researchers come up with the great algorithms, and then it's like you have people that start to apply it and figure out that they actually work. And then it's like they gain adoption. And so where I think right now is like, I know of 27 algorithms in the data science world that actually are relevant, that we know have produced valuable results for certain scenarios. And so I think one of the first things we'll see is like that commoditization of those algorithms, how to apply them over data. And so imagine that somebody has their data in the cloud already, in some Hadoop cluster, for example, that they host inside maybe Azure. And now it's like you want to do some analysis. Well, within the new Hadoop 2.0 is like with Yarn, where it's like you can plug in new applications on top of them. I can imagine writing some data analysis tool that uses one of the algorithms, applies them, and now you have results. And now it's up to you to interpret them, and then you need to get the last mile, and how do you get it into Excel, because the business analyst, he doesn't read JSON files or XML. Like, he needs it in a format that he can use and create a graph of, right? And the last mile problem will always be an interesting problem, because like you need to get it into the hands of the people that can make decisions.
Right.
And executives most of the times are not the people who are doing the crunching.
Right. But they want their data yesterday.
They wanted their data yesterday, but they also don't know what to ask. Right? And this is another role of the data scientist. And it's like, and that's I think more the creative role, and it's like,
Absolutely.
It's the combination of what information can I derive from data, combined with the aspect of like, how do I know the business? If you don't understand the business, you don't know what questions to answer, to be honest.
What to look for even.
Yeah. It's like, I would be useless if you put me in an insurance company, because I don't know what questions to ask. I have an opinion probably, but it's not my business. I don't have the domain expertise. So you need that combination, and that's what the challenge is. You need to get that data combined in the domain expertise. And that can only happen if you drive the requirements for data science down to a certain commodity first.
Right.
And so that's the first step that needs to happen. I think Microsoft can play a good role in that. I think data science as a service might be an interesting opportunity to actually go and in that direction and start working on that.
Right, it's very interesting. So big data and the way Microsoft handles that is going to reshape data warehousing.
It certainly will. I don't think that the current form in which we build data warehouses today is going to be long lasting. I expect over the next 5 years that new projects will start to leverage the new ecosystem that is available.
Right.
I'll give you an example of how people are using Hadoop in the cloud today with HD Insight. So during daytime, they upload information. I think this is in the financial branch. They upload information into their storage accounts, and then at night they spin up 100 nodes Hadoop cluster. They do the crunching and spin it down. They collect the results, and then they do and then they have the reporting when the market opens. They have their results.
Right.
And it's very cost efficient because they pay per minute.
Right.
And so
don't pay up front, right?
And you don't pay up front. And if they have more data or they have more analysis, they might have to scale to 120 nodes, or I don't know how many nodes they might need. But it's completely elastic, and it scales with the needs and the business requirements. Right, so it's like if the data is no longer needed, well, then they spin it down. They will no longer use it, and they now don't have this massive investment that they have to write off.
Right.
Right. They don't have to maintain it. They don't have to initialize the clusters. They just say, like, I need 100, and I'm going to push my work to those 100 nodes. It happens. It comes out, and you spin it down.
Yeah. If you calculate it over the next 10 or 20 years, Microsoft will save companies billions, right?
It's like, I think there is a cost saving in terms of TCO, right? Mm-hmm. Total cost of ownership. In operational cost, right? Imagine it's like the operational cost that you would have to maintain these things, and your capital expenses.
Right. Plus the benefit from flexibility.
And the benefit in terms of the instant availability.
Right.
Because I cannot get 100 servers ordered, installed, in production.
In seconds.
In minutes.
Okay, maybe right. Minutes. Right.
But it's like it takes me weeks to get the machine. I need to have the space, I need to have cooling, I need to have the power supply, I need to have the staff to initialize it and maintain it. So I'm now 3 months down the road, if I'm lucky. I've seen organizations where this amount of service would even take longer.
Right.
And so I think that's where the differentiating aspects are with regards to cloud computing, big data, and being able to host that and use it on demand.
Right. Last point, not unimportant. Last point, not unimportant. Hadoop on Windows is an open source, publicly available thing, right?
Mm-hmm. Yep.
Together with Hortonworks, Microsoft developed it, produced it, and gave it back to the community.
Mm-hmm.
Now the community is looking at it and adding feature after feature after feature.
Yep.
Where will that end? Where will that lead to?
So there are a couple of interesting aspects of what you just said. So let's first touch on the Hortonworks collaboration. Mm-hmm. So we're working together with Hortonworks is like to produce the Windows distribution. So one of the desires that we had was like, we want to have a Hadoop installation that runs perfectly on Windows, that is super well integrated with the Windows platform, and that is optimized for the Windows platform.
Right.
So Microsoft has an engineering team working together with people at Hortonworks to achieve that. Hortonworks produces the distribution, as we call it. So you go to the Hortonworks site, you download the latest MSI, and that already is a very different experience than, for example, if you look at the earlier Hadoop installations for other platforms. It's like to install a Hadoop cluster, well, you install Java, you install Python, and then you run the MSI. That's what it's to it. And so we're trying to reduce the friction for somebody to set up a Hadoop environment to begin with. If you, of course, host it, it's like the friction is even lower, but it's like that's the whole point of being hosted, of course. But we use the same kind of mechanisms there as, of course, our distribution mechanism for spinning up instances is like we use other copy techniques, but so Hadoop is an integral part of that, and so all the commits that we're making actually flow back through Hortonworks into the community. With the introduction of Hadoop 2 and the changes in the way that the execution model works by the introduction of Yarn as the new resource manager, replacing the job tracker, you see a whole set of new applications coming up, which enable very interesting scenarios. Look at, well, I'll pick two, like Storm, something created by Twitter, which does complex event processing over real-time streams of data. They use it to analyze their Twitter feeds.
Right.
It's like a perfect example of a big data problem that can be used in other areas and can now therefore be run onside that same Hadoop investment. So because that's the way I look at it. It's like before, it's like you had a Hadoop investment, and even if you had your own cluster, you could run MapReduce, and that was it. And so what we started to see at the end of the Hadoop 1 life cycle, if I might call it, it's not that, but it's like we now have 2, is that people were starting to misuse MapReduce. They would try, there's a project that will start Apache websites on your Hadoop nodes by retrofitting it into the MapReduce model. Basically, you had a mapper that spins up an Apache website and an empty reducer. And so that thing was always in the map stage. Never finished, emits status to the node. And why would they do that? Well, like I have, say, 500 nodes and I need a bunch of web servers. And so I want to use some capacity, but I don't want to take it out of my cluster. With Yarn, I now have the ability to do these kind of things. I can take HBase and use it for HBase capacity. I can use it to do Giraffe, which is a graph compute framework that allows me to compute graphs over data sets that don't fit in a single node. Which is like, wow, that's an interesting problem. Think back to that insurance company guy.
Right.
It's like, I need to correlate all these things. It's like, I want to know the social graph of this person. Maybe they have all the ancestry information of a person in there. And they want to correlate that. It's like, maybe you don't want that, but it's like, it happens. They do it today. They might not be as open about it. And so there's a whole set of scenarios that will be enabled. And that's what the new model will allow us to do. And so you see a bunch of applications popping up. And the way it will work is like you have Hadoop components, which are fitted into a distribution, which we then host inside a cluster. And so it's like there will be some lag time between certain projects showing up. One of the most interesting ones right now is TESS.
Right.
And TESS is a way to represent a distributed graph as execution without having to materialize the results as you have to do in a MapReduce kind of environment. And if you think about interactive kind of workloads, you don't want to persist the data all the time. And if you can take out a bunch of persistence points out of a graph of MapReducers, your performance goes way up. And we already seen that. It's like Hortonworks actually published some results about how they rewriting Hive to use TESS as the underlying model.
Right.
So instead of taking the SQL query and turn it into MapReduce, they turn it into TESS, which is a directed graph, and execute that. and that already yields tremendous results. So we're just at the beginning of the capabilities of Hadoop. I think this will be a great ride into the future.
Sounds like a definitely great future. Thank you for the interview.
You're welcome. Thanks, Tony.